Let us take one more example on partial differentiation. So if u is equal to x square tan inverse of y by x minus y square tan inverse of x by y, then show that partial derivative of u with respect to x and y, our second order partial derivative of u with respect to x and y is equal to x square minus y square upon x square plus y square. We have given that u is equal to x square tan inverse of y by x minus y square tan inverse of x by y. Let us give it equation number 1. Now, since we have to find out the second order partial derivative of u with respect to y and x, right? So we have to first differentiate partially with respect to y. Then we have to prove that, we have to prove that del to u del x del y equal to x square minus y square upon x square plus y square. Differentiating one partially with respect to y first. We have del u del y is equal to partial derivative of this with respect to y. Okay. Now, here, if you want to find out the derivative of x square into tan inverse of y by x with respect to y, x square is constant, so we can take outside. Then the partial derivative of tan inverse of y by x with respect to y. And in the second part, partial derivative of y square into tan inverse of x by y. Now here, if you want to find out the partial derivative of y square into tan inverse of x by y, we have to use the product rule. So let us first find what is the derivative of tan inverse of y by x with respect to y. So we know that what is the derivative of tan inverse of x? It is 1 upon 1 plus x square. So in place of x, it is y by x. So we can write down 1 upon 1 plus y by x whole square, or we can write down y square upon x square. Again, what is the derivative of y by x with respect to y? It is 1 by x. So this is the first part, our derivative of tan inverse of y by x with respect to y. In the second part, since we are using u into v rule, the first one is the u and this second one is the v. So first function u square, derivative of tan inverse of x by y. So this is 1 upon 1 plus x square. X is what? It is x by y whole square. So x square upon y square. And again, derivative of x by y with respect to y. So what is the derivative of? What is the derivative of y? 1 upon y with respect to y. So it is nothing but derivative of y to the power minus 1, or we can write down minus 1 into y minus 1, or y to the power minus 2, which is equal to minus 1 upon y square. So now here, just look here. What is the derivative of x upon y? X is constant, so we have taken outside. And derivative of 1 upon y is nothing but minus 1 upon y square. This is the first part, first function, derivative of the second function, and plus derivative of y square is 2y. Derivative of y square is 2y. And this minus comes because this is already minus sign, so we have written minus sign over here. And into second function, tan inverse of x by y. Okay, so let us again try to simplify it. X square, this one is x square, and now if we write down this one is 1 plus x square y square upon x square, so LCM is x square. So x square into x square, and this x square goes to numerator. So we can write down x square into x square upon x square plus y square, and this is 1 by x over here. I think this is clear to everyone. What is the value of this? Is nothing but x square upon x square plus y square. In the same manner, here this is y square, this can be written as y square plus x square upon y square. This y square goes to numerator. So we can write down y square over here minus x upon y square. So this y square and y square will cancel. This 1x and this x will cancel. And the last one is a 2y into tan inverse of x by y. So let us try to again simplify it. It is nothing but x cube. This will become x cube and this is plus xy square whole divided by x square plus y square minus 2y tan inverse of x by y. So let us give it equation number 2. This is the partial derivative of u with respect to y. Now if you want to find out the second order partial derivative of u with respect to x and y, then we have to again find out the partial derivative of del u del y with respect to x. So let us go ahead. Differentiating 2 partially with respect to x, we have partial derivative of del u del y with respect to x. It can be written as del 2u del x del y. And we know that what is del u del x? It is nothing but x cube plus xy square upon x square plus y square minus 2y tan inverse of x by y. We want to find out the partial derivative of this term with respect to x. Now, let us again separate these two terms. Partial derivative of x cube plus xy square upon x square plus y square with respect to x, and minus we have taken outside partial derivative of 2y plus tan inverse of x by y with respect to x. Now, since here this is also the function of numerator is function of x and denominator is also function of x, and if you want to find out the derivative of the function which is in the form of u by v, then we use the u by v rule. And similarly here, this 2y is constant, we can take outside. So we are directly find out what is a partial derivative of tan inverse of x by y with respect to x. So now here, how to use the division formula? The denominator x square plus y square into derivative of the numerator x cube plus xy square minus numerator x cube plus xy square and partial derivative of denominator x square plus y square whole divided by denominator square means x square plus y square whole square minus 2y we can take outside and partial derivative of tan inverse of x by y. So let us try to find out. This is the same. What is the partial derivative of x cube? It is nothing but 3x square. Partial derivative of xy square, so y square is constant, and derivative of x equal to 1, so we have only y square remaining. In the second part, x cube plus xy square, it is same as it is. Now we want to find out the partial derivative of x square, which is 2x, and partial derivative of y square with respect to x is nothing but 0 because x and y are independent variable. In the next term, this is 2y into what is the derivative of tan inverse of x? It is 1 upon 1 plus x square. So in place of x, it is x by y. It is x square into divided by y square. And again, derivative of x by y with respect to x is nothing but 1 upon y. So this y and this y will cancel. Let us again try to simplify it. We have to just multiply this one. So x square into 3x square is 3x to the power 4. X square into y square is x square y square. Then x square into 3x square is 3x square y square. Then y square into y square is y to the power 4. And now there is a minus sign. So 3x cube into 2x is 2x to the power 4 and it is minus 2x to the power 4 minus 2x square y square and whole divided by x square y square whole square. In the same thing over here, if we take the LCM of this one, it is y square. So x square plus y square and y square goes to divided by y square. So y square goes to numerator. It is 2y square upon x square plus y square. Okay, let us again simplify it. 3x to the power 4 minus 2x to the power 4 is only x to the power 4. 3 minus 2 is 1. Similarly, x square y square, 3x square y square is 4x square y square minus 2x square y square. So 4 minus 2 is 2x square y square and plus y to the power 4. And here minus 2y square upon x square y square. Let us again simplify it. It is nothing but x square plus 2x square y square plus y square whole square, x square whole square. So this is nothing but x square plus y square whole square divided by x square plus y square whole square. This 2 will cancel. We have 1 and we can write down 1 minus 2y square upon x square plus y square. If we take the LCM upon this is 1 also. So LCM is x square plus y square. So x square plus y square minus 2y square. And the plus y square minus 2y square is nothing but minus y square. Therefore, del 2u del x del y is equal to x square minus y square upon x square plus y square. This is the desired result, hence proved. Thank you.